Hello, Jeff.
Hello. How are you?
Fine, Jeff.
Okay. What time you come back from school?
Oh, 1:10.
1:10. Children have gone to school. I told you already. You will be too tired to study. Okay, let's carry on. Okay, quantum physics, topic 24. I can look at the analysis for you. Right? At least 3 questions will come out. Sometimes one particular topic will have 2 questions, like this one and this one. Right? 3 questions per year. And popular one is this section, photon, wave particle duality, and X-ray. Okay, let's go to what are the things you need to remember. Under photon, you need to remember what is photoelectric effect. You need to know this formula and what does H and F stand for. Right? This is the energy of the photon. And speed of light is frequency times wavelength. And intensity is power divided by cross-sectional area, normal to the surface. And the power is just your number of photon per second times your energy of photon. And remember the law, there are 5 of them. Okay. Number of photon emitted per second depends on intensity, is proportional to intensity. And then the electron are emitted with a range of velocity from V equals 0 to V equals V max. And then V max is dependent on frequency, independent of intensity. Emission will occur if your frequency of electromagnetic radiation is greater or equals to your threshold frequency. Then know that the emission is instantaneous. As soon as it shines, the electron is emitted from the surface of metal. And there's Einstein's equation to explain your photoelectric effect. And you have your threshold frequency, right? Know what is threshold frequency, know what is work function. The work function equals to H F naught, right? F naught is your threshold frequency. And know the equation, the graph, this graph there, right? Where there is your gradient, there's your y-intercept, and this is your F naught. And this one, how to get the stopping potential is from this equation. And under wave particle duality, right? The Brody's equation, or the Brody's wavelength. And now that you can relate kinetic energy to momentum. And then if you accelerate electron to a potential of V, there's the kinetic energy of the electron where it reaches the anode. Now what is emission line spectrum? Okay, this is initial or E to E, the n+1 level. This is the nth level, right, or final level. And how to calculate the energy of photon. Energy of this photon is from the difference in energy level. Then usually the electromagnetic radiation emitted is Hc over lambda. right? Or HF. Usually you will give you lambda or ask you to calculate lambda. The atomic structure, right? Know your centripetal force equals to your electrostatic force. For stable orbit, there's your Bose postulate. For stable orbit, there's your angular momentum is quantized. And the second, know that then know the total energy of the electron in the orbit. I can put an N there if you want to. And Rn equals to this one, and memorize it. And energy between two levels. This one is in electron volt. Under your X-ray, there is your intensity wavelength graph, right, of the X-ray that is coming out from the tube there. Know the function of different parts. And the power is just that accelerating potential times your current passing through. Right? Tube current, that's a tube current. I and E over T. The number of electron reaching the target. Okay, this is your STPM box. Right? Current is NE over T. Sorry. Number of electron. Okay, and know how to interpret. Right? These are the equations that you need to remember. Right? That one there, where your Q is 0 lah. Then this will be your maximum frequency or minimum wavelength. Right? Now to explain the continuous distribution. Right? Know how to explain the spikes. And Bragg equation. There's an incident ray. There's a Bragg angle or glancing angle. There's the plane of the atom. Then Bragg's equation. Remember that? Nano science very rare come out of us. Just come out 1 year. Okay, anything that you want to ask? Yep, Srini, anything that you want to ask? Anything not clear?
No, Chair.
Okay, question 1. In an experiment on photoelectric effect, a target material is irradiated with a beam of monochromatic light. Which action causes the rate of emission of photoelectron to increase? Yep.
C, teacher.
Say again.
C.
No. Frequency control the speed. A. Right? As intensity increases, think of intensity as the number of photons with a particular energy. Increase intensity, increase the number of photons falling on the surface per second. Greater intensity, more electrons emitted. Intensity decreases, falls, right? That will decrease the number of electrons emitted. Light of lower frequency, false frequency affect the maximum kinetic energy of the electron. Okay, the answer is A. a flashlight emits a beam of light with power 3 watt and an average wavelength 330 nanometer. How many photons are freed by the flashlight per second? Yep, what's the answer? All this should have been done at home already. Then we can go faster in the class. Yep.
The answer is boy.
What formula to use?
P equals to NHC over lambda.
Okay, calculate your energy. Right, that's your Planck's constant. That's your speed of light. Wavelength, that's your wavelength. Convert it to nanometer. Calculate the energy. Then use your P equals NTE divided by T. You want number of photon emitted per second or the rate. Okay. Just take the E down. Your P is 3. Your E is there. Okay.
Okay.
In photoelectric effect experiment using monochromatic light, some electrons emitted with a maximum kinetic energy because
Donkey.
A, the incident photon have the same energy. Basically, we are just using this equation. Maximum kinetic energy equals energy of photon minus work function. Donkey, correct? It's not a random process, as the emission takes place only when illuminated by electromagnetic radiation of certain frequency. Work function is the minimum energy required for emission with zero velocity. Okay, photo electron emitted from metal surface have a maximum kinetic energy, which depends on
C.
Okay, good. We are just using that equation, that's all. Right? Instead of that one, we can use this one. Intensity determines the number of electrons emitted. Amplitude means the intensity is larger, that's all. Right? So determines the number of electrons emitted per second. Wavelength of incident radiation, wavelength determines the energy, this energy. And maximum kinetic energy, W is constant. The area illuminated, area illuminated determines the number of electrons emitted per second. Okay. The transition between energy level for hydrogen atom produce 3 spectral lines of wavelength lambda 1, lambda 2, lambda 3 as shown in the diagram below. If lambda 1 and lambda 2 are given, what is the value of lambda 3?
A, teacher.
How do you derive it?
No, the lambda 2 minus lambda 1.
Cannot do like that. You have to go to the equation. Right? There's a different energy level. That's the wavelength emitted. So EC to EB, there's a lambda 3. And EC to EA, there's a lambda 2. And then EB to EA, there's a lambda 1. Okay, so 2 minus 3. 2 minus 3, because you want this one, EC minus EB. Okay, 2 minus 3, so it's EC A will go off, EC minus EB, EC minus EB, and this one minus that one, no? And equating these two, 1 and 4, they are equal. This is HC lambda 3, HC lambda 2 minus HC lambda 1, and HC can cancel off. So eliminating. So we can remember the equation. It's not adding the wavelength. It's reciprocal. That one is just this one, reciprocal of this one, minus reciprocal of that one. That's the equation. Okay. Answer is donkey. Anything not clear?
Teacher, all the HC become 1 because it's all the same, right?
It's the same. You just cancel it off. Divide by HC. No? Divide by HC. Anything else not clear?
Clear, teacher.
Okay. Then let's go to number 6. Why does an electron microscope have a higher resolving power than optical microscope?
Donkey.
Right? Know your formula for resolving power. So it depends on aperture or wavelength. So wavelength smaller, resolving power is better. Right? So donkey is wrong. A is false. Electron travel slower than visible light. No. Even though this is not the criteria that we are looking for, even though it's true. Electron have a charge, but visible light, that's not a criteria also, right? Not the reasoning for resolving power doesn't come in about visible light. Electron has a charge or moving slower, it doesn't come into the equation. This one is true. Shorter wavelength, this one is smaller. Higher penetrating power doesn't come into penetrating power. Penetrating power depends on energy. Right? So false. That's not the criteria we're looking for. The answer is C. Okay.
Okay.
7. If alpha particle and photon are moving with the same de Broglie wavelength, which statement is true about the alpha particle?
C.
Okay, let's see. Right, there's your de Broglie equation. For alpha, just take this one across, that one down. For alpha is that one. For proton is also that one. So you are told they have the same wavelength, they are equal. H and H can cancel, so they have the same momentum. Right? EA, EB, same momentum, so you are right. So A is wrong, B is wrong, C is true, D is false. So answer is C. Good. What is the de Broglie wavelength of photon with kinetic energy 100 electron volt? Can see a lot of calculation involved. Yep, what's the answer? Or what formula to use?
P equals to H over lambda.
Say again.
1 over 2 mv square equals to the kinetic energy.
Right? Either you memorize that kinetic energy equals to related to momentum or derive it. Doesn't take a lot of time. Then your momentum. Right? The Broglie wavelength depends on momentum. So that's why we are calculating momentum. Just take across there. And calculate your momentum. Right? That's your 2. That's your proton. Get your from your value of constant. Then this one, kinetic energy converted to joule, right? 100 times 1.6 times 10 to the power minus 10 joule, calculate out. Then use your de Broglie equation relation. Calculate again. Okay, boy. Okay, anything not clear?
Yeah.
The total energy of the nth orbit in the hydrogen atom is given by the equation there, where M and E are mass and charge of the electron respectively. What's the de Broglie wavelength of the electron in the nth orbit? Yep. How to
This I'm not sure, sir.
say again?
This I'm not sure.
Okay. If they give you your total energy, you should be able to calculate a kinetic energy. Yeah, it's the same formula, except you don't have the negative sign there. This is your second term work. Sorry. Your first term work. Right? Same equation for kinetic energy, except no negative sign there. And calculate your momentum. Right? Same as what we did just now. This one. Okay. Put your this one inside there. Right? M square becomes square root of m square becomes 1m. Square root of this one becomes e square. Then 2 divided by 8, you still got 4. Square root of 4 is 2. Then square root of this one, you get epsilon naught. Square root of this one, you get h. Square root of this one, you get n. Okay. And the Broglie wavelength, the Broglie relation, put in your value, h times your momentum. That's all. The answer is A. Okay. Anything you want to ask? Anything not clear?
Not sure.
Okay. The particle of mass m, kinetic energy E, what's the de Broglie wavelength of the particle? Answer? Yep. That's your kinetic energy. Right? Calculate your momentum for kinetic energy. Just cross multiply. Take the 2m across there, then square root it. Then use your de Broglie relation, h over momentum. Place your momentum here. Answer C. Okay. Okay, number 11. A hydrogen atom can undergo transition state when collision occur between the hydrogen atom and electron, or when interact with a photon. Energy level for 3 states in the hydrogen atom are shown in the diagram below. Which statement is not true about the transition? Yep, what's the answer? Okay, looks like you are having problem again. Right, the minimum energy required for transition is this one. That means 13.6 minus 3.4 is 10.2. Right, so here looking at electron. This one is possible, right? Because the electron can cause a transition, and then this incident electron will leave with the rest of the energy. So A is true. The energy of the incident photon is 13.6, sorry, 13.0. The electron which will be excited from electron will be excited from E1 to E3, E1 to E3. So you subtract, you get 12.1. So it's possible the electron will give this energy cause a transition, and then the electron will leave with the rest of the kinetic energy. Energy of incident photon is 10.2. 10.2 is just nice to go from E1 to E2. Energy of incident photon is 11.2, 11.0 electron volt. Electron will be excited from E1 to E3. E1 to E3, you need, you subtract that is 12.1. So it cannot, the energy will be somewhere there. It's forbidden. So D cannot be the answer. So D is a false answer. Okay. Anything not clear? I already told you don't go for school. Then at home then I won't be so tired. Which statement is not true about the Brody atomic model for hydrogen atom? What is your answer?
Donkey je.
The electron move about the nucleus in circular orbit. That's true. The total energy of electron in the allowed orbit is constant. True. Angular momentum of electron in the allowed orbit is quantized. True. The electron radiated electromagnetic radiation when they orbit the nucleus in allowed orbit. False. In allowed orbit, no radiation is emitted. So the false one is your donkey. Electron in an X-ray tube are surrounded through a potential of 10 kilovolt. What is the minimum wavelength of the resulting X-ray? Okay. What is your answer? Yep. Right, the equation. Energy
HC over lambda equals the potential.
Energy of your photon. There's a work done on the electron. Then cross multiply the EV down, put in your value. There's your H, there's your C, there's your charge on electron. This one, change it to SI unit. Calculate out. The answer is C. Okay, anything not clear? The characteristic line in X-ray spectrum is produced when? What is the answer? Yep. What is your answer? All this you must be on your fingertips already.
Yes, Voyager.
Okay. Electron knockout the incident electron knock out the electron in the inner orbit, and the electron from the outer orbit move in to fill up the inner shell. So electromagnetic is irradiated when the electron move to the inner orbit. Okay, good. B. X-ray of wavelength 8.4 × 10⁻⁻10 meter incident on a crystal. The third order diffraction of X-ray occur at a glancing angle of 24.5. What's the separation of the two adjacent atomic plane of the crystal? Okay, what's the answer? Can see a lot of calculation involved in this topic.
This one, 2D sine theta equals to m lambda, so the answer is C. Bragg's equation.
Okay, good. You need to memorize your Bragg's equation. Which statement explains the existence of minimum wavelength in X-ray spectrum?
Donkey.
Okay. Donkey is true. The incident electron lose all its kinetic energy and produce a X-ray photon. So donkey is correct. Okay, that's the equation. The atomic plane spacing for crystal structure using an X-ray diffractometer is 0.3 nanometer. If the wavelength of incident X-ray is 0.154 nanometer, what is the maximum order of X-ray diffraction observed from the plane? Yep.
So, C, teacher.
Use the same equation. Maximum order, always put your sine theta equals to 1 or theta is 90 degrees. Then you want your n, take your lambda across, put in your value. No need to change. 2 times your 0.3, and wavelength, that's your wavelength. They are basically nanometer. Okay, C, correct. You cannot round it out to 4. 4 will be greater than 90 degrees already. Which statement is not true about nanoscience? So nothing much memory work.
Boy.
Okay, boy is false. You're right. Okay, now let us look at section B and C and try to understand what is coming out. Okay, doesn't come out every year. Right? You can see that this one comes out, this year doesn't come out. But okay lah, quite almost like every year lah. Popular subtopic, atomic structure, atomic structure, atomic structure. Right? It does come out X-ray also, but others are not so popular. Using Bohr's model for angular momentum, estimate the speed of electron moving around the nth orbit that is allowed in the hydrogen atom for the state n equals to 3. The radius of the third orbit is given. Okay, what formula to use?
MVR equals to NH over 2 pi.
That's the formula to use. NVRN equals to NH2 pi. And you want your estimate the speed of the electron in the in the third orbit. So take your Rn and m down, put in your value, right? N is 3, H is Planck constant, get it from your value of constant, and 2 pi mass of electron. Mass of electron. That one is R, given there. Okay.
Okay.
The energy level of hydrogen atom at various states is shown in the diagram below. What would happen to a photon of 12 electron volt and 10.2 electron volt when they pass through a stable state atomic hydrogen vapor? Yep. What happened to 12 electron volt?
Unable to cause excitation of the hydrogen atom.
Okay. How about 10.2?
Able to exceed the electron.
Okay. 12.2, 12.0 cannot because it's here. Sorry, it's about here. Right? 10.2 will go to the second level. Right? From first level to second level. So photon of 12 electron volt will not cause any excitation but pass through the vapor. Photon of 10.2 will cause excitation to energy level n equals to 2 as 13.6 minus 3.4 is 10.2 electron volt. Okay, good. If the excited electron experience a transition from N3 to N1, determine the wavelength of photon that are emitted. Okay, how to do that? What formula to use?
E3 minus E1 equals to HF.
E3 minus E1 equals HF.
Yes.
Right? Convert your frequency to wavelength. And this is E3, this is E1, and that one there. You want to find wavelength, take your E down. That is emitted as your electromagnetic radiation. H is 6.3. This is your H. That's your C. And that is your that level. And there's that one there. Right? Electron volt, you have to convert it to joule. So we times 1.6 and 10 to the power minus 19. Okay. Anything that's not clear? It looks all right. You can calculate. Okay, let's go to section C. Right? The derivation of Boyle's model is popular. Right? Make sure you know how to derive that. Describe the Boyle's atomic model. Yep. Two marks, make sure you get at least 2 points. Can
Electron move in circular orbit around the nucleus.
Then
Orbit are discrete energy level which have a lot of energy.
no, electron move in circular orbit around the positive nucleus. For stable orbit, the angular momentum is quantized. Right? You can write that equation down. Then tell what is M, what is V, what is Rn, and then what is H. Okay. Then if you want, you can add in if the electron move from a higher orbit to a lower orbit, electromagnetic direction is emitted. Okay, maybe we will just add that in. State the weaknesses of Boyle's atomic model for atoms other than hydrogen-like atoms. Yep. 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 Boyle's atomic model is unable to predict the energy level in complex atom. Right? For hydrogen atom, you can predict. A complex atom, those with more than 2 electrons, cannot predict. The model cannot explain the relative intensity of the spectral line. Okay. This part, as I say, may want to add in right? May want to add in electron moving from higher energy orbit to lower energy orbit emits electromagnetic radiation. Okay, in case your examiner required you to do that. Okay, let's go to the next part. Hydrogen atom at the end state has an energy level given. Yeah, they're very kind to you. Sketch the energy level diagram for 3 lowest energy states of the hydrogen atom. Yep. I should be able to sketch that. You can mark yourself. Right? You have to calculate out because they have given you the formula. 3 marks, they expect you to calculate the 3 energy level. Right? For 1, n equals to 1. Calculate out. n equals to 2, right? And n equals to 3. Calculate out, not memorize, then draw. Okay, that's your n1, n2, n3. You can put the energy level the other side if you want to. And then just tell them this is in electron volt. Why am I so careless? Okay, with that, anything not clear? Mark yourself. Determine the wavelength of photon emitted when the excited electron atom at n equals to 3 return to ground state. Right? Remember, ground state is 1. So basically, you already calculated there. That one there. And that one there. Right? Or can just use the equation. No? Right? There's n3, n1. Subtract that. Get electron volt. Convert it to joule. Okay. Lambda take down. Take E down there. Take lambda up. Sorry. Take E down there. This is your H. This is your C. The energy is that one. Times 1.6 to change it to joule. And calculate the answer is in meter. Okay. Any comment or anything that is not clear? Yep,
Okay,
finish.
clear.
Okay, clear. Then let's carry on. Calculate the wavelength of photon which is able to ionize the atom at ground state. Okay, ground state is just the energy level, this one, this value. Okay, same as before. H, C, 13.6, which is this one. Change it to joule. Calculate out. State 2 series of line spectrum obtainable from the hydrogen atom and state which one is visible. Okay. State for me. Yep. What is the answer?
The answer, acha. Lyman and Balmer series.
Yep.
Balmer is
Lyman and
visible.
Balmer series. Balmer series is a visible spectrum. Okay, let's go to number 2. State Bohr's postulate. Derive the expression for orbital radii of atom in Bohr's model. Right? Postulate 1, electron move in circular orbit around the positive nucleus with a quantized angular momentum. That's your quantized momentum formula. Postulate 2, when electron move from a higher energy to a lower energy electromagnetic radiation is given out. The difference in energy equals to HF. H is Planck's constant, and F is the frequency of radiation. Right? Derive, consider electron or charge E and mass n moving in circular orbit of radius r around a positive nucleus of charge E. I hope we have derived that. Then electrostatic force equals to centripetal force. Right? That's your centripetal force. That's the electrostatic force. Take your V, take your M down, your R up there. Right? R cancel off, you still got one R there. Then M take it down. And your momentum is quantized. That's the formula. Okay, so we have derived up to this stage there. Okay, now that one. Take your sorry, that's your square this one. Right? Take your M down, take your Rn down, and square your V square because you want the V square to replace that V square there. Okay, so that's why we get square this one. And then this one is just that one there. The V are equal. Then you want your Rn. Take this Rn across there. Right? 4 pi cancel, you still got a pi there. That one there. M, take across there, you still got 1m. And n square there. H square there. Epsilon, you take across there. Epsilon not. Okay, good. Anything not clear? You should be able to derive it. Came out 2 years already. Yep. Anything not clear?
So why the MVR equals to NH over 2 pi formula?
Say again.
Why is it MVR equals to NH over 2 pi formula?
Which one are you talking about? This one.
Yeah.
This one is your electrostatic force equals centripetal force. That's your centripetal force. That's electrostatic force. There's a second term work. I just missed out one step here. That's all. From here. Right, maybe you can add a step in so it become clearer for you. How come it doesn't want to obey me? Okay, it's obeying me. So I basically take my M down here. And take my Rn down. Right, and this part I just squaring. That's all. Okay, if it's clear, let's carry on.
Okay, sir.
Okay. energy level of a hypothetical hydrogen-like atom, as shown in the diagram below. What is the ionization energy? What is meant by ionization energy? Yep. Can or not? Ionization energy.
No, sir.
Ionization energy is the minimum energy required to remove an electron which is in the ground state. There's electron that's just able to become free electron with zero velocity. That means it's from the ground state to energy level zero electron volt. During the transition of atom from level N3 to N2, a photon of wavelength is emitted. Calculate the ionization energy for this atom. Express your answer in electron volt. Unnecessary calculation. Okay, you need to memorize this formula. En is E naught, N2. E naught is this one, right? E naught is this one. Okay, so you want N3 to N2. Calculate out. These are in electron volt. Right? Remember, we are just using is the formula. Where's the formula? We are just using this formula, except you must know that this is your ionization energy. That's all. And we represent it as E naught. That's all. Right? I think it's not clear from here. Maybe we can put another step. Let E naught be the why is it so slow? Sorry, take a while. I don't know why it's so slow. Not doing what I want it to do.
Teacher can stop here actually.
Let me just finish this part.
Yeah, 2, then 3 and
That's
4.
why I told you don't go to school. You don't want to listen. You go to school already, you're tired, you no time to rest.
Next week I know you to go school.
That's why I said no need to go to school already because you don't gain anything. It's better to study at home. When is your
No,
physics
they
exam?
still teach.
When's your physics exam?
Wednesday.
Wednesday. Monday? Monday is what?
Monday, no school.
Oh, Monday no school lah.
No
Okay.
God, but then like I don't see necessary to go, so I'm not going.
Yeah, no need to go. You can rest at home and it can more effective to study. More time to study. Save your traveling time. Okay. Use that equation. Right? And then there's your energy that's emitted. Energy of photon. Use that equation lambda hc over E and put in your value. Right? Lambda is given you. Lambda is given you. Right? Change it to meter. Then H, there's your C. And then your E, there's your E. Replace your E. Right? Remember this is electron volt. You have to convert it to joule. And calculate your E naught. Okay.
Okay.
So ionization energy is always from infinity, which is this one, minus the ground state. So 122.4 electron volt. Why will certain mineral glow under ultraviolet light? Basically, this is applying your knowledge, that's all. Yep. Can?
Can.
What is the answer?
Ionization energy is the minimum energy required for removing an electron from the ground state to infinity.
This didn't ask you about what is ionization energy. That one is over already. You're not paying attention in class. They're asking you why certain mineral glow under ultraviolet light.
Oh, because when electron absorb photon, they exceed to higher energy level.
So it's not complete.
So when the excited electron jump to the ground state, the difference energy is released.
No, not ground state. Right? Like this hydrogen atom, the minimum energy required is ultraviolet. So ultraviolet depends on the energy. It can go to N2, it can go to N3, it can go to N4. So when the electron move down, it doesn't go down to ground state straight away. If it goes to ground state straight away, it will be ultraviolet. So you can go to N2 or can go to N3, right? N3 or N2. That is where you second level is visible. That's your Balmer series. That's how you should explain. Right? Electron in the atom absorb ultraviolet light to jump to a higher energy level. As electron jump to a lower energy level, visible light is given out. Right? If you want to add in, you can add in. This one I don't agree with the answer in your book. That's why I put a red sign there. Right? Since it's 3 mark, you have to add in a little one more point. Sorry, we are finishing. Electron. move to electron move to level n equals to 2, not ground state directly. When it goes to ground state directly, it will be ultraviolet, so you won't see any visible light. It's just application. Okay with that? Any comment? Anything that is not clear? If it's clear, we'll stop today. Since you are too tired already, I told you don't go to school, you don't want to listen.
Teacher, they force me to go to school. I can't do anything.
Or they force you. That is very cruel.
They say I must go.
That's very cruel. I thought this is a time we should let you all stay back and study. If you find beneficial, then you go.
No, not the school. My parents, grandparents.
You should explain to your parents. You say cannot. You learn nothing. Better to stay at home because you got tuition class. After that,
No, I mean the teachers do teach it. So.
Okay. Okay. Anything you want to clarify? If not, we'll call it a day.
Call it a day.
I know you're too tired. Okay, we'll call it a day.
Okay, thank you, sir.
Bye-bye. See you tomorrow, 9 o'clock.
See you tomorrow, sir.
Make sure
Bye.
you do your last topic. If we got the time, we will try to cover all the others. Okay, can go.
Okay. Sure.
Yeah.
The tomorrow class can have it on Monday then.
Why you want to keep on postponing it? You need time to study. It's up to you.
Then tomorrow lah.
It's up to you because I say your exam is coming very fast. It's better to spend the rest of the time study rather than have tuition. Unless you got things urgent one you cannot understand, you want to ask me, then can that one I won't charge you, as I told you already. Okay, so tomorrow
then
try to do some of the exercise past year question.
9 o'clock.
9 o'clock.
Okay.
Okay, we'll stop there.
Bye, sir.
Bye-bye.